Nice. Okay. So do you want to go over the mind map?
Sure. So this is the mind map for the dynamics, mass, and weight. So first of all, we have forces, which is a vector, um, and forces it's divided into two types: contact force and non-contact force. So about contact force, we have air resistance, tension, friction, and normal force. So air resistance is just shows in the image right here. It's like when you ride in a bikes and you can feel like the wind going against you. That is a resistance. Normally we walk around, we also have a resistance, but it is too small to notice. The second one is tension. It's like a rubber band, like when we stretch it out, the force that we can feel, it's the tension. Um, so we have friction, which shows in the image is when the car is moving and the wheel, the tire, is in contact with the road or the ground, and um it creates a friction that goes uh the opposite way of the motion direction. And lastly, we have the normal force, which is um the force that going from the middle, that going up perpendicular to the ground. Um, yeah. And the second type of force is the non-contact forces. So in here we have three force: electrostatic, gravitational, and magnetic force. First of all, we have electrostatic force. It's like two atoms or anything like have the different charge, positive and negative, it will attract to each other, or the same charge, positive, positive, or negative, negative, it will repel from each other. Second one, we have the gravitational force. It's the force that helps us to stay on the ground. Like shown in the image, the ball stays on the table because of um gravitational force, and there's also a normal force going up, and it's perpendicular to the table. Last we have magnetic force. It's kind of the same to electrostatic force, because like poles, I mean unlike poles, sorry, I got it messed up. But unlike poles, like south and north here, it will attract to each other, and like poles, it will like north and north, it will repel from each other.
Okay, so remember to change it because it's important.
Yeah. Another thing about dynamics is mass and weight. People usually misuse weight and mass like in daily life. So mass is the amount of matter in an object, and the SI unit for it is kilogram. Whereas weight is the gravitational force acting on an object that has mass, and the SI unit is Newton. So the relation between mass and weight is that the weight is, or the gravitational force acting on an object, it is directly proportional to the mass, to the object's mass. Because we have the here we have the gravitational field strength formula, which is G equal to W over M, so that we can see that W is equal to G times M. So it's directly proportional. So here we have gravitational field, which helps the weight, and it is a region in which a mass experiences a force due to gravitational attraction. So that will give us two. It's gravitational field strength and the acceleration due to gravity. So first of all, it's the gravitational field strength. On Earth, it's 10 Newton per kilogram, and on Moon, it's 1.6 Newton per kilogram. So it is different on different planet, the gravitational field strength. So for example, if the weight of an object on Earth, it's um the weight of an object on Earth and the weight of that same object on the moon, it's different, but the mass is still the same because it's the matter in that object, it doesn't change, but the gravitational force is changed due to different places. And the last one, we have gravitational field strength and the acceleration due to gravity. Um, The formula for that is F equal ma, where F is the resultant force, m is the mass, and a is the acceleration. We have the acceleration, the force here is equal to gravitational field strength equal to 10. Yeah, that's all I got for chapter 3 about dynamics.
That's very good. I really like it. I mean, I can feel that you read the materials very well, and I like the mind map that you did for the weight and the mass. It's very good. Like, I don't think there's many things to add to it, and I like the way you do the arrows because we can see how it connected to each other. How do you feel about this one when you make it, when after you've done it and you have a look at it? What do you think?
Feel like great when I see, improvement on my map making skill. Like the dynamics, this is the last one, the dynamics one, and like compared to the first one, it's just text and there's no, you know, drawings to represent it. So I feel great about my map.
Yay, yeah, I like it too. It's very customized and you have the important information on it. Mm-hmm. Okay. Do you want a little bit feedback about the information that you have here?
Yeah.
Okay, sure. Do you want to change the notes about the magnetic force first, like the like poles and the unlike poles?
Oh, yeah,
That's
yeah,
the
yeah,
important thing. Yeah.
yeah. Um,
Mm-hmm. Awesome. I just have a little bit feedback about the information that you add for each kind of force here. Do you want to go up a little bit to back to the air resistance?
air resistance.
Yeah, like to
Yeah,
the contact forces
yeah.
here. Like you mentioned again, like when we study force as a vector, which information that we need to know in order to draw a good vector of force? Which information that we need to know? We need to know about, okay, so how can we demonstrate a force on a diagram?
We use of force. We use a arrow.
Yes, so with an arrow, we need to know the direction, right?
The direction. Yeah.
Mm-hmm. The tail, the head, and also the magnitude, right?
Yeah.
Uh-huh. And you have learned the difference between the magnitude and the algebraic value, right?
Yeah.
What's the difference again?
The value, the algebraic, it's related to the direction motion. The motion direction, like the motion direction is the plus sign, like the a positive value. So the other way around, it's gonna be negative. Where the magnitude, it doesn't matter on where the motion direction is. It's always positive.
Mm-hmm. So it's just like the length of the vector. So
Yeah.
that's why it's somewhat positive. Yeah. So remember that because it will help when we solve problems to do with forces or like the free body diagram. A diagram that we analyze many forces acting on the same object. Okay. So here, if you remember the direction of each force is here by demonstrating as an arrow, it's okay. But I just want to emphasize that you need to remember, like for the normal force, the direction have to be like perpendicular to the contact surface. Do you want to note it on the diagram? Or are you sure that you will remember it?
I can sure that I will remember.
Okay, so then we don't have to, as long as you can remember that thing. And so like for the friction here, we say that the friction will resist the motion, so it will oppose to the motion direction, right?
Yeah.
But that's just for sliding friction or kinematic friction.
Oh yeah, about static friction. Yeah.
Yeah, that's right. So static friction will be something too. So I think that we will cover it later today or when at the time that we really need it. So just make sure that you will like have two different branches inside friction, okay?
Okay.
So yeah, that's it. The other part is good. Yeah. Okay. So and come back to the mass and the weight. I just have a little bit thing to add here. Um, to the equation F equal ma.
This one.
So how can you relate this equation F equal ma to the G equals W over M?
So the A, it's gonna be all right. So we have G equal to W over M. So the W will be um G times M.
Mm-hmm. So what does it mean?
So it means that W will equal to M times 10 because is equal to 10 Newton per kilogram.
So what does it mean about the G here, the nature of G?
The measure of G is the
Yeah,
gravitational field strength.
right. It's the gravitational field strength. But like from the equation that you just derived related
Oh
to
yeah, okay.
yeah.
All right. So, mm,
Do you want to write down? Write down. It can help make sense a lot. Just write it down in the details, then you will see it.
I mean like I don't know how to say it, but so the we have G equal to, so from that equation we can have W W equal to mg
Yes.
equal to 10 times no, I mean m times 10 times 10 Newton per kilogram.
Yeah, agree. And if you compare this one with F equals ma, what is the
Yeah,
conclusion you can have about the G, the nature of G? I agree that G is the gravitational field
G is
strength.
equal to A, which is
Uh-huh.
equal to 10,
So
because
when
the acceleration is 10 meter per second square.
yeah, true. So that's the nature of G. It's also the nature of G. G is not only the gravitational field strength, but it also the acceleration due to gravitational
Due to
force.
gravity. Yeah,
Makes sense?
yeah.
So do you want to note it here about the unit for that value of 10, the G?